Okay, let's go ahead and do some applications of derivatives. Now, in these applications, we're also going to do some graphs because they're going to be economic applications. And I want you to start getting used to this because these graphs will become increasingly complicated throughout the rest of the videos in this series. In both this section and the next section, when we start getting into really sort of hardcore graphing using derivative analysis. So anyway, so let's assume that we have a cost function. So this is total cost, which equals 3q cubed minus 4q squared plus 6q. Okay, now I want you to recognize first that what is this cost function missing? Well, it's missing fixed costs. So this is all variable cost right here. Okay, so just get used to looking at cost functions and just being able to write right up front. Just say, okay, these are my variable costs. Because remember the definition of variable costs from introductory microeconomics. It are costs that are a function of Q. Well, these costs here are a function of Q. If I added a constant on to the end, say plus 17, that is not a function of Q. Okay, when Q is 0, I still owe 17. Well, that's my fixed cost. Okay, so anyway, let's wipe that out. So this is my cost function. Revenue is a function of Q equals 15Q. Okay, so now, okay, one thing I want you to remember is whenever you hear the word margin, in economics, it simply means take the derivative of some primary function. So when we're looking for marginal cost, it is simply the derivative of the cost function. So that is C prime of Q, and of course that equals 9Q squared minus 8Q plus 6. When we're looking for marginal revenue, that is simply the derivative of a total revenue function. So marginal revenue equals R prime of Q, which in this case is constant. It equals 15. Now let's graph this. In fact, let's look specifically. Let's do this. Let's identify the profit maximizing, identify profit maximizing output, okay, output, wish I could spell, identify profit maximizing output, okay, let's see, identify the shutdown point, okay, that is where, of course, if price drops below that point or that level, the firm shuts down in the short run. This should be familiar to you from introductory microeconomics. Let's see. And calculate profit at Q star. Okay, so calculate profit at the profit maximizing output level. So let's do this. Okay, so in identifying this, we're going to just simply graph it. Okay, so let's construct a graph over here. Now remember, you got to label your axes. If you don't label your axes are completely meaningless, okay? Now I'm going to put dollar signs up top. So this is dollars, this is quantities, okay? Remember, always label your axes accordingly. If we were looking specifically for profits, I would probably put a pi sign up here for profit, okay? And then that would be quantity, like we did in some videos earlier. But in this case, we're just going to put dollar signs up there because it's both costs and what we're going to find is actually prices as well. Now, the first thing we need to do is look at what kind of industry type this is. We can see right away, because marginal revenue is constant, that this is a purely competitive industry, otherwise known as perfectly competitive industry. How can I tell that? Because if you remember, under perfect competition, the price equals the marginal revenue, which equals the demand for the firm, okay? And this, in this case, happens to be equal to 15, okay? If marginal revenue was not constant, it would be imperfectly competitive. It would be an imperfectly competitive industry. In other words, it would either be a monopoly or a monopolistically competitive firm. But in this case, we can look at how marginal revenue is constant and be able to tell right off the bat, this is perfect competition. Okay, so the next thing we need to do is identify the profit maximizing output level. Well, as we know, the profit maximizing condition is where marginal revenue equals marginal cost. And in this case, it would be 9q squared minus 8q plus 6 equals 15. Now what we're going to do is solve for q. So this gives us 9q squared minus 8q minus 9 equals 0, and this is where we break out the quadratic formula. So the quadratic formula will say that q equals 8 plus or minus the square root of 8 squared, which is 64, minus 4 times 9 times negative 9, all divided by 18. So simplifying this a little, before I put it into my calculator, just because it makes it easier, we get 8 plus or minus the square root of 64. Let's see, that's 81 times 4. 81 times 4 equals that, plus 64 equals that. Square root of 388 divided by 18. Okay, so let us now calculate Q. So Q equals, let's see, 8 plus square root of 388 divided by 18 equals 1.53. Okay, now here's the thing. This is going to give me a symmetric point somewhere over here as well, okay? And that's going to become important later, especially for average variable cost. Why do we need average variable cost? Because average variable cost is where our shutdown point is, okay? So just bear with me here. But right now we're working on the profit maximizing output level, and that is going to be at Q equals 1.53. If you calculate the other Q, that would be 8 minus the square root of 388 divided by 18, which is or Q equals negative 0.65. Okay, so positive 1.53 okay, that is where marginal cost equals marginal revenue. Now what does our marginal cost function look like? Well, it looks like that. It's got an intercept when Q equals 0, it's got an intercept of 6, okay? And we know it's going to come down like this, okay? How do we know that? Well, because again, this is going to be the symmetric point, okay, over here. So this function actually comes up like this and crosses over here at negative 0.65, okay? We just don't need to show that on the graph. But why is this important? Because now we have symmetry. We can look at, or we can take 1.53, okay, let me put it on here. We can take 1.53 and we can add to that 0.65. That gives us a distance of 2.18 between those two. Okay, you with me? Now, we divide that in half, divided by, divided by 2. That equals 1.09. What I'm going to do now is I'm going to take 1.53 and subtract from it that answer, okay? And that gives me 0.44. So right here, 0.44. Now, I start off by saying we know marginal cost looks like that. How do we know that? Well, other than the fact that we have two intersections with marginal revenue, this is the next indication that marginal cost has to look like that. At Q equals 0.44, what does marginal cost equal? Well, that would be 9 times 0.44 squared minus 8 times 0.44 plus 6, 4.22. Okay. In other words, the intercept was at 6, okay? That's the intercept right there. The curve, then the bottom of the curve is at 4.22, which is lower than 6. And the bottom of the curve is to the left of 1.53. So this function has to be U-shaped like this, okay? Got it? Okay, so now we have found this equals Q star, and we'll call this Q star PC for perfectly competitive profit maximizing output level. We're not done yet, so we've identified that and we've graphed it, okay? Now we need to identify the shutdown point. Now the shutdown point is the minimum of average variable cost, okay? Remember that from introductory microeconomics. Now we also know that marginal cost crosses average variable cost at average variable cost's minimum, okay? So here's how we can find the shutdown point very easy. We take the average of total cost, and in this case, again, that's easy because this is only variable costs. There are no fixed costs. Otherwise, you would be taking the average. In order to find average variable cost, you'd be taking the average of just the terms with the Q's in them. But in this case, it's easy because all the terms have Q. So, what is average variable cost? Average variable cost equals this divided by Q. So that's 3Q squared minus 4Q plus 6. That's average variable cost, okay? Now, how do we find the shutdown point? Well, we know that marginal cost crosses this at its minimum. We know this also has an intercept of 6, so we know average variable cost comes through here, okay? It starts at the same point marginal cost does. So what does this function look like, and where is its minimum? Well, we're going to do two things here. We're going to set average variable cost equal to marginal cost first, okay? So that means that marginal cost equal to average variable cost implies that 9Q squared minus 8Q plus 6 equals 3Q squared minus 4Q plus 6, okay? The 6's cancel out. What do we get? We get, let's see, 6q squared. Okay, it takes care of that. Minus 4q equals 0. Okay, so we can factor out a q. We get q times 6q minus 4 equals 0. Okay, so q equals 0, or q equals 2/3. Okay, now 2/3 is 0.67. That means that AVC crosses MC at 0.67. Why does Q equal 0 as well? Because they both intersect at the vertical intercept at 6. So it makes sense that MC and AVC cross each other twice, once at that intercept and then once right here. So this function must go like this. Now we need to assure ourselves that this function looks like this by finding this point here. Okay, and what does that point equal? Well, that is where AVC equals 15. So 3q squared minus 4q plus 6 equals 15. So we have 3q squared minus 4q minus 9 equals 0. We'll plug this into our quadratic formula. We get q equals 4 plus or minus the square root of 16 minus 4 times 3 times -9, all divided by 6. So this equals 4 plus or minus the square root of, let's see, that is 9 times 3 times 4 plus 16 times the square root of 124, all divided by 6. 6. Okay, so we're looking for a positive value here, so we're going to say that q equals 4 plus the square root of 124 divided by 6 equals 2.52. So that is 2.52. Okay, so we know that this function looks like this. Now we still haven't calculated the shutdown point. This is simply the Q value of minimum AVC. It is not the shutdown point. The shutdown point is the price at that Q. Okay, so what is the price at that Q? Well, that's where MC and AVC intersect, so we can plug that 0.7 either into MC or into AVC and get the same answer. And you can try that on your own and see. You'd get the same answer. What do we get? So we'll just plug it into MC. So marginal cost at 0.67 equals 9 times 0.67 squared minus 8 times 0.67 plus 6 equals 4.68. Okay, so that at 4.68 is the shutdown point. So that is the shutdown point. Okay, this is the profit maximizing output level. Now we need to calculate profit at Q star. Okay, so that's Q star. What is profit? Well, profit, I don't know if I was off. So there, yeah, okay, so I was probably off camera a little bit, but that 4.68 is the shutdown point. Okay, then 1.53 is Q star. That is the profit maximizing output level. Now we have to calculate profit at Q star. Okay, so what is profit at Q star? Well, profit, of course, is total revenue minus total cost. So profit at 1.53 equals R at 1.53 minus C at 1.53. Okay? Now, R at 1.53 is simply 15 times 1.53. So that would be 15 times 1.53 equals 22.95. Cost at 1.53 would be 3 times 1.53 raised to the third minus 4 times 1.53 squared plus 6 times 1.53 equals 10.56. Okay, so then what is profit? Profit at 1.53 equals 22.95 minus that answer, which gives me 12.38 approximately. Okay, 12.38 approximately. So let's go ahead and clean this graph up, okay, and fully complete our question. So completing our graph, or going ahead and cleaning it up some, our graph looks like that is 6. The shutdown point is at 4.68. That is the shutdown point. Okay. That is 1.53, and this equals Q star PC. And it's always good to go ahead and put the Q at the shutdown point, and in this case it's 0.67. So that would be our complete graph, and the profit is 12.38. So that is a complete firm model. Now granted, it's a simplified form of what we're going to do later on. And it took quite a bit of calculations to get to here. But that said, you've just modeled a firm. This is the first firm you've modeled from beginning to end. And this is economics. Now again, it's going to get more complicated than this, and we're going to do a couple more examples in this area, but now you see how it's done. You need to go ahead and duplicate this. Make sure you can do it step by step, because the next two examples I do, we're going to go ahead and go